We're going to go over changing the base of exponents, essentially to help us solve for maybe unknown variables. And the first one is just going to kind of get used to that process. So what we're going to do is we're going to make these all have a base, and we're going to have the exponents, we're not going to write them as roots, we're actually going to write them as fractional exponents. So this is a square root. Do you know what number technically sits here?
2.
Yeah, 2. And how can we write 64 to an exponent instead of having that root? Do you know what that is?
64 is the power of 1/2.
Yes, perfect. Okay, so we'll change this to 64 to the power of 1/2 multiplied by, okay, and the same idea with this 128. How can we rewrite that?
128 to the power of 3/4.
Yes, that's right. 3/4. Good. Okay, so now that we've done that, what we want to do is look for bases we can write these in. Okay, so we're going to look for values or numbers that we can rewrite this. So we could think of values that might equate to both of these. So for instance, we know that this can be broken into maybe 8 by 8, right? 128, off the top of my head, I don't know any. It's probably going to need to be a power of 3 or a power of 4. So we can test a few when going through this. 64 is also a multiple of 2, right? And I get a good feeling that 128 might be a multiple of 2 also. One way we can try to test this is by breaking it into prime factors. And when we go through the prime factor process, you might end up with like a factor of 2, 3, 2, 3, which really means 2 and 3 aren't the factors, but if you go a step up and you go 6 and 6, well, 6 and 6 can be written as a base with an exponent. So we know this goes by 8 by 8, but let's actually break this into prime factors and see if it can be broken into anything else. And you might not have to do this. You know, off the top of your head, you might be able to solve it, but we're going to do this so that we have a process and a reason to know. So what are 2 factors of 64?
8 and 8.
8 and 8, yeah, they work very easily. And can we break 8 and 8 up?
2 and 4.
Yeah, 2 and 4. And can we break those into any more basic factors?
4 can be 2 and 2.
That's right. Okay, so that means we can either break 64 into 8 to the power of 2, or we can have it written as 2 to the power of what? How many 2's are there?
6.
6, that's right. So we have an option of 8 to the power of 2 or 2 to the power of 6. And we're going to use whichever base is more beneficial to us in this question for simplifying. We'll do the same thing with 128. So what are some factors of 128? And you might not know any off the top of your head, so one of the easiest ones might be to start with is, what would you think if it's an even number?
2.
2, right? That's a really easy one to start with. Okay. So do you want to divide, if we divide this by 2, what will we get?
64.
Yeah, it goes in, 2 goes into this 6, yeah, 64, perfect. Okay, and that already gives us information because we know from 64, we can break 64 into 2 sets of bases, right? We can either break it into 8 by 8, but then that doesn't really help us because we already have a 2 on the side. Or we could break 64 into what power, or base of 2?
2 to the 6.
That's right. This can be also written as 2 to the 6. So instead of 2 to the 6, we obviously have an extra 2 attached to it. What can we write 127 as?
2 to the 7.
2 to the 7. Okay, now I probably should have done these calculations on the side, but what we're going to do is we're going to replace, let's get our highlighter here, we'll replace 64 with 2 to the 6th, and we'll replace 128 with 2 to the 7th, okay? We'll still keep those other exponents there, okay? So let's go down. This now becomes replaced, so we've gone a whole nother step. Becomes 2 to the power of 6 times the original, which was a half.
That's okay.
Yeah. Times, and this one becomes 2 to the power of 7, and it was technically multiplied, or its exponent was 3/4? Yeah, 3/4. Now, essentially what this says is we have 2 exponents times each other. So if we have 2 exponents times each other, how can we simplify that? Do you know what we can do?
Multiplying the exponents?
Yeah, let's multiply the exponents, so we're left with just the base of 2 numbers. So this becomes 2. What is 6 times a half?
2 to the power of 3.
Yeah, 2 to the power of 3 multiplied by This one's a little more difficult.
21 over 4.
Yeah, essentially 21 over 4 doesn't really simplify. But we can simplify this exponent. We can add the fractions together, right? And to add them together, I'll have to change this exponent to a fraction. So with it as a base of 4, how would we write that?
12
Yeah.
over 4.
Yeah. Multiplied by 2 to the power of 21 over 4. And then from there, what do we do with our exponents?
We add them.
We add them. So this will essentially say 2 to the, what is 12 plus 21?
33.
33 over 4. And that doesn't really break down any more than that. Okay, so, but this is all written as one base. And this can be very helpful when going to solve things. So, let's go up to this example here. We have 2 questions. And in this one, their bases are different, which can make it hard to solve when we use our logarithms. So what we're going to do is we're going to try to make these, both the bases have the same base exponent. Now 2 we can't really break down, but can we break 4 into some base of 2?
2 squared.
Yeah, exactly. And that's a pretty simple one to look at. 2 to the power of 4x is equal to, and this becomes 2, and then 2 times our x plus 3. Okay. From here, I'll simplify that exponent expression there. So we have 2 to the power of 4x is equal to 2 times 2x plus 6. I just used distributive property. And now technically our bases are the same. So the idea is we can essentially drop them off. Now the reason this works, and we talked about, is we've used logs. So if you haven't used logs before, we have, you can just kind of do this to solve it. But since we've used it, we'll kind of go through the proof. We'll find the log of both sides. So we find log of 2 to the power of, I guess we'll put it in black here, 4x is equal to log of 2 to the power of 2x plus 6. Now what can we do with those exponents? With our logs, do you remember what we can do to simplify this?
We can bring it as a coefficient.
Yeah, exactly. It becomes the coefficient in front. So we now read 4x times log 2 is equal to 2x plus 6, and I'll kind of put it in brackets so you know it's a coefficient, of log base 2. Okay, well, I can divide because this is essentially multiplication by log. If I bring this log base 2 to the other side, it becomes division. And what is log base 2 divided by log base 2?
1.
So we end up with 4x is equal to 2x plus 6, when really we didn't have to go through the logs because, like we said before, our bases are the same. We cancel out. We would have ended up with 4x is equal to 2x plus 6. But this is essentially our proof with logs on how we simplified that idea. From here, it becomes just strictly a linear equation we're solving for x, right? So we bring this 2 over. It becomes 2x is equal to 6, and x is equal to 3. Does that make sense? Yeah.